Assalamualaikum and hi everyone. Today we're going to present about our project IDP, which our title is Car Cabin Intellivent System. Before I start the videos, I'm going to introduce myself. I'm Syafiqah binti Rashidan, and then the next presenter will be Sumed anak lelaki Udom, then Muhammad Takif bin Zamirin, and the last one is Asma'an Nasrul Takif. In this video, we will focus on problem statement, objective, car Intellivent system, target audience, visual inspiration, project software, project result and conclusion. We spend hours in our car completely unaware of an invisible hazard. Humans are natural carbon dioxide factories, and in a sealed car cabin with standard air recirculation turn on, carbon dioxide level can spike into dangerous level in under 20 minutes. This lack of proper ventilation creates a suffocating environment that directly trigger drowsiness, impair decision making and fatal micro sleep. We aren't just facing tired driver, we are facing a critical ventilation failures that turn everyday commutes into a life-threatening blind spot. Hence, in this project, our objective is to design and develop a portable prototype called the Car Cabin Intellivent System. The reason is to solve the real problem of poisoning of carbon dioxide and microsleep risk in stationary vehicle.
So the problem we have is CO2 build up rapidly inside a parked car when windows are closed and AC is on recirculation. Levels above 1000 ppm cause drowsiness, dizziness and microsleep. Most vehicles have no monitor, no automatic ventilation and no location sharing. Look at this graph. The red line shows pure ventilation with windows closed. CO2 keeps rising. The shaded area marks medium and higher danger, drowsiness, loss of focus, and severe lethargy and microsleep risk. Near the green line, our car ventilation system, we detect CO2 with the SCD41 sensor at 1000 ppm warning threshold. Then we ventilate our car using trio fans, intake plus dual exhaust fan. Finally, the system and the geolocation respond with buzzer on, telegram bot and send GPS location. The green line drops back to safe levels, no microsleep, no danger. That's how we protect the users from any accidents. In the next slide, our system is designed for 4 main groups, which is our target audiences. First, long distance travelers, people who rest inside parked cars with air conditioning running. Second is smart tag and RFID users, drivers who spend long periods waiting at toll plazas, checkpoints and drive-thrus. Third, commercial drivers, taxi and e-hailing drivers who often sleep in their vehicles during breaks. Fourth, also long distance travelers because they are our primary focus. They face highest risk of CO2 build-up and microsleep. These are the people who need the car Intellivent system the most.
Okay, so this is the design for the body of our project. So this is the front view of the project. As you can see, we put 2 fans at the front here and then 1 hole here for LCD screen. The LCD will display the ppm for the ppm of CO2 in our car. And of course, the fan here is for ventilation to suck in the CO2 when detected. So here you can see there's 2 holes here. This is for the power outlet and this is for the SCD41 sensor. This sensor will be the sensor that detects the CO2. Next is the bottom view, and as you can see we have another fan ventilation system here. So why we put 3 is to maximize airflow, and then also other than ventilation we also use it to cool the components inside of the body. So other than that, we also put most of our components in the body, including ESP, buzzer also we will put inside here. So here's the back of the body. As you can see, there's a hole here. So when the air is sucked into the body, this is where the CO2 will be expelled from. So this part will be located outside of the car. And other than that, we also have our compartment here where we will put our GPS module. So the GPS module will detect our location in case of unforeseen emergency, and it will send a signal into Telegram to alert other users that uses the Telegram also. So that is all for the design. Thank you.
Okay, so this is our breadboard prototype, and here we have a microcontroller ESP32, and then we have a few resistors here located, and there's a transistor here for the buzzer, and MOSFET for the fan. Now let's go for the battery. This is a supply for a fan, and we have 3 fans here. And next one is our SCD41 for a sensor, and then we have LCD display and a GPS tracker, and also an antenna.
Now I will talk about the coding session. We have 3 phases here. So the first is the setup boot sequence. First is hardware initialization. The ESP32 locks its pin into place, making sure the fan and the buzzer start completely turned off. Next is network and comms to connect the Wi-Fi hotspot to the Telegram bots. Next is sensor wake up. It power up the LCD screen and test SCD41 CO2 sensor and start reading background serial data from Neo GPS. Lastly, it's all clear to send single Telegram message on the phone. Now we on the phase 2, the data gathering. So we have two here listening to the sky, which is for the GPS to found the satellite and update its coordinate. Next is breathing the air. It asks SCD41 sensor to read the CO2, and it say yes. It grab the exact part per million number and print it into the top row of the LCD. Lastly is phase 3, the brain. We have 3 level here. So the first one is a good state under 500 ppm. The air is safe and the buzzer will turn off. LCD will say good and message to the Telegram. Next is mediocre. State 500 to 1500 ppm. The air is getting stuffy and the fan will turn on and buzzer is still off. Lastly is the danger state over 1500 ppm. The hazardous gas will out as occur. The fan will stay on and the buzzer will on, and also the GPS will grab lift coordinates and send to the Telegram.
So this is the result of the project. Firstly, the CO2 will be detected using the SCD41 sensor. If it's above 1000 ppm, the fans will be activated to disperse the CO2. And also, the buzzer will be turned on to alert the driver in case the driver is in microsleep state. And after that, there will be a Telegram alert sent that will display the ppm levels of the CO2 and will also display the location of the driver through the GPS module.
Hello, so this is how our project function. So here we have our microcontroller here and the sensor over here. So when the sensor detect the carbon dioxide, it will show on the display LCD here, which show ppm level 880 and status mediocre. And then when the status pop up mediocre or above, the fan will move. This is the fan is moving right now, so you guys can see it, and it will suck the carbon dioxide from this part, and it will go all the way at the front here. We have uh spaces. I believe we have spaces that will come out through that. So yeah.